Hi, welcome to USMA Logo. This is Chapter 6, Ionic Reactions. So this is an exciting time because we're finally getting into doing reactions more in depth. So in general, there's 4 types of reactions in organic chemistry. So in this chapter, we're going to cover 2 of them. And when we're done, hopefully you should be able to apply these concepts to many of the future reactions that we study in organic chemistry. So the first thing we're going to talk about, and we're going to do this often for most of the chapters, is we're going to talk about some naming and some physical properties. So you can take a look at that when you're going through your reading. Not too much different than what we've seen before. Mostly naming is review, and then physical properties. Really, it just addresses solubility at this point, and it goes back to the idea of like dissolve like. Organics will dissolve in organics rather than water. So there's a lot of key terms in here, and these key terms we're going to pick up and use for quite a long time for the rest of organic chemistry. So it behooves you to figure them out now. So the first one is nucleophile. So this concept of nucleophile and electrophile is going to be used for the rest of organic chemistry. So a nucleophile is something that has extra electrons to donate. An electrophile is something that is deficient in electrons. So you should be able to differentiate between 2 of them. An example of nucleophile maybe would be, just a hydroxide ion, where you actually have extra electrons that they can donate. And electrophile is usually something that's positive, or even in some cases water can act as a electrophile, in that the oxygen can take electrons from somewhere else and form another bond. Then you're going to talk about the concept of leaving groups. So a leaving group usually has electrons, takes electrons as it departs, and the better leaving groups are those that are stable once they come off. So that's something to pay attention to. You'll use the term substrate in the reaction schemes, and then solvents will start differentiating between different types of solvents. So the solvents is where the reactions take place most times, and they do have an effect on the reactions that's going to proceed. So there's 2 major types that we worry about at this chapter, is polar aprotic versus polar aprotic. So take a look at those and understand the differences. Then we're going to go into carbocations and then their stability. So the carbocation is very important to understand because that'll dictate what type of reactions and what type of things make it stable. So try to figure out what makes a carbocation more stable. And then transition state theory is a way to relate the energy with the reaction and how you might be able to predict whether one would be favorable or not based off its energy. And then finally, mechanism. We started using these a little bit in the past, but here we're really going to understand how to use these to illustrate a way that the reaction will proceed. So it kind of makes sense of the reactions. And if you understand mechanisms, it makes being able to predict things a lot easier as well. So the first one we're going to talk about is SN2, and this is right out of your book. But basically what you have here is a negative hydroxide, brings a pair of electrons, and if you pay attention, it actually attacks on the back side of the carbon, so opposite of where the leaving group is, which in this case is the bromine. Then you get a transition state. This little diagram is how you annotate a transition state, and then you finally have the bromine gets kicked off and is substituted by hydroxide. So that's why we call this a substitution reaction. And if you realize what happens, the stereochemistry gets inverted. So because the hydroxide comes in the backside and the bromine leaves, then the stereochemistry gets inverted. So, and that's what this is trying to explain down below. And quickly looking at the reaction energy diagram, you can see that we go from a certain energy, you go up by the transition state, but then you go down to the lower energy at the end. So take a look at that. Now SN1 looks a little bit more complicated, but it's not too much. The big thing you got to understand with SN1s is that you got to have a stable carbocation. So that 1 means that it's a unimolecular reaction. It only depends on one of the reactants to begin with. So in this case, we're only worried about this reactant, and the rate limiting step, or the slow step as it says here, is having that chlorine come off. And once we do that, we create a carbocation. That carbocation is what's important to drive the rest of the reaction. So once you get that carbocation, then it's going to be easy for even a weak nucleophile to attack, like water. It attaches, and then just to complete the reaction, instead of having a positive charge here, you get another water that'll pull off that hydrogen and make it an alcohol. So, and you can take a look at the reaction energy diagrams over here, where in this case we have multiple steps, so we kind of have different humps that illustrate the different portions of the reaction. But in each case, you go to a transition state, and then an intermediate, then transition state, intermediate, transition state, intermediate. So take a look at that. Next is the E2. So now we're going to talk about an elimination reaction. So we're going to eliminate something. In this case, usually we're eliminating a hydrogen and another species, in this case hydrogen bromide. So this strong base is going to pull off that hydrogen. The electrons that were in this bond are going to go to there, and that in turn is going to kick off the bromine. So you can see the transition state here. But at the end of the day, we get a double bond compound. So we lose a hydrogen, which is a green, and we lose a bromine in this case. So they are eliminated. And there's also an E1 mechanism. So E1 mechanism looks very similar, except in this case the chlorine comes off first, creating carbocation, and then in this case water pulls off the hydrogen. Those electrons go down to that bond, and you still get an alkene when it's over with, but you have, in the reaction energy diagrams, you have two steps rather than one. So throughout the book, there's some of these charts that are very good and helpful. You really want to try to build your own understanding and charts of, the factors that affect one reaction versus another. Like good things to pay attention to is the substrate, the nucleophile, the solvent, and the leaving group, and sometimes even temperature. So if something is tertiary, you're going to get SN1, but if something's primary, you're definitely going to get an SN2. So it's those type of differentiations that you want to be able to understand, so that when you look at a reaction, you can tell what's a different type of mechanism it's going to go by. And down here's another table out of your book that talks about some of the differences of all the different reactions. And at the end of the book, there's a good summary that kind of goes through when you're going to see an SN2, SN1, E1, and E2 reactions. So take a look at those. Try to organize your thoughts such that you understand those primary differences between the different types of reactions, and you'll be set. All right, that's it for today. Can't wait to see you in class. Have a good day.